All right, hello once again, Jeff Scott of Rankin Technical College, and as part of the Rankin Technical College AWD1000 Web Development Technologies course, I've been creating a series of video presentations that I'm basing on the textbook that we're using for the class, and that book is the PowerPoint slides from Xerox, JavaScript, and jQuery 4th edition. I've done all of the first section. I started on the second section, just did chapter 8, and now I've finished chapter 12. So I'm up to 13, how to work with control structures, exceptions, and regular expressions. So I'm going to handle that, and then these next three, and probably then these three, and then come back to do 9, 10, and 11, if you care. All right, so let's, without any further ado then, let's get going with chapter 13. How to work with control structures, exceptions, and regular expressions. So, as always, we begin with our applied objectives and our knowledge objectives. Again, some of this stuff has been already covered in earlier lectures. Some of it we really didn't talk much about try, catch, and finally we'll talk about now. All right. Now, notice here they've got the equality operator and then they have the identity operator. I'll be honest with you, I very rarely use the equality operators anymore. In essence, just about all the time, I use the identity operators. And remember the difference between the two. With the equality operator, all right, if this was the number 3 and this was the string double quote 3 double quote, that would return true. But with the identity operator, with 3 of them, it would not. And just like there's a double equals and an exclamation point equals, there's a triple equals and an exclamation point double equals. All right. Now, I believe we've talked about break statements, and I believe we've talked about continues, but maybe we didn't. So let's quickly bring those up in here. So I'm dealing with something else there. So I showed you this a long time ago. I said int LCV equals 1, while LCV less than or equal to 10. And we did an alert where we said, in fact, we will do a template literal, LCV equals and plus plus LCV, like that. And that literally is going to print out LCV equal 1 space. Let me just throw this all in there. So that'll be 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Kind of what you'd expect. But what if for some reason when I reached 7, I wanted to break out of the loop? All right. So I could come in here and do this. I could say if LCV equal 7, break. Now, the difference will be, and I'm going to just take all this, I'm still going to say LCV equal 1, LCV equal 2, LCV equal 3, LCV equal 4, LCV equal 5, LCV equal 6. But now when it gets to 7, it'll break out of the loop. So because it'll be equal to 7, so it'll go down to whatever is right here. So that's a break. There's also continue. So in that case, I'll have LCV equal 1, LCV equal 2, LCV equal 3, LCV equal 4, LCV equal 5, LCV equals 6, but now it's going to skip 7. So it won't do that. But it will go then to the next one, LCV equal 8. Equal 8. LCV equal 9. Finally, LCV equal 10. So you can see the difference. If I don't have that and I just alert it out, I'm going to get this. The ones that are here. If I put in the break, I'm going to get to that point, but then I'm going to break out of the loop. And if I put a continue there, I will skip that iteration. So I'm skipping the 7 iteration and going on and doing the rest. That's the easiest way that I can explain it to people, is to kind of just show it to you like that. So there's break and there's continue. Switch we've talked about, I think, but let's do this and let's talk about why you wouldn't want to use a switch. All right. So let's pretend for a second I'm gonna go and just completely get rid of the program that I just made. All right, and I'm gonna say here, let number grade equal, and we'll do a parse int and a prompt, which will say, please enter grade. And we'll even try to make it easier, 0 through 100. Now, I'm not going to go and we'll just default it to a 75. All right. I'm not going to go to all the trouble of checking for not a number and checking for numbers less than 0 and greater than 100. I'm just going to pretend the person knows what they're doing. That's a dumb assumption to make, but I just don't want this program to get too unwieldy. So I could come in here and say this: if grade greater than or equal to 90, I'm going to assume 90 is up, 90 to 100 is an A, 80 to 89 is a B, etc. So if grade is greater than or equal to 90, we will put a little bit in here and we'll say and grade is less than or equal to 100. So if it's one of those, we're going to come in here and say, we'll say here, let letter grade equal the empty string. Okay, so if this is the case, letter grade equals A. Should be pretty, much straightforward. Now let's go in and let's copy this. Otherwise, if it's greater than or equal to 80, it's a B. And this should be an else. Else, if it's greater than or equal to 80, it's a B. Else, if it's greater than or equal to 70, it's a C. Else, if it's greater than or equal to 60, it's a D. Else, let's put a more compound check in here. So I'm going to grab this one from here. And I'm going to say if it's greater than or equal to 0 and it's less than 60, it's an F. Now, and this will be an else if. So else if. And we'll finally come in here and we'll put in an else. And we'll say else. We'll just say letter grade equals invalid input. Okay, we're keeping it real simple. So we're asking the user to come in here and enter a grade. Let's say they say 87. Is 87 greater than or equal to 90? No, it's not. So since we're using an and, we got short circuiting, we don't even check this. Since that's false, we skip this. Is 87 greater than or equal to 80? Yes, it is. So it's going to set letter grade equal to B, and it's going to skip all these. Let's do it again, and we'll use a 70. All right. 70 is not greater than or equal to 90. It's not greater than or equal to 80. It is greater than or equal to 70, so it'll set letter grade here. All right. Let's do it again with a 55. That's false. That's false. That's false. That's false. It is greater than this and it is less than this, so it'll set it equal to F. If it's 100, it's not in there. That doesn't meet that, doesn't meet that, doesn't meet that, doesn't meet that. So it's going to set it to invalid input. If it's -6, the same thing. All right. And if it's NaN, we could have checked for that at the beginning, but I didn't. Now, that's how you do it with an if. Now, you would not do this. You would not do this with a switch. You could, but let's just quickly look at why you wouldn't. So I'm going to do a switch here on number grade. All right. And the way I'd have to do that is like this. I'd have to say case 100, case 99. I'm just going to copy this down so you see it. Case 98. Case 97, case 96, case 95, oops, case 95, case 94, case 93, case 92, case 91, case 90. Now, if it's one of those, now I can come in here and say letter grade equals A and then break. Then I'd have to do the same kind of thing, and I'd have to put in here 89 down to 80. So you can see how many of these I would have. All right, that would be ridiculous. So if you're doing something that falls within ranges, you want to use if statements. You don't want to use a switch. All right, but let's do this. Let's write this quickly. I'm going to make it simple. I'm going to say let size equal prompt. Please enter your size. And we're going to assume there's 4 of them. And they are small, medium, large, and extra large. And we will default it to, medium. All right. And here we won't even have anything here. So we put that in. And now I'm going to say size equal size dot to uppercase. Okay. Now I can do a switch in here on size, and I can say case S, case S, and come in and say something like alert, you are a size small. Let's put a capital S in there. And break. Now you can probably figure out, I'm going to get rid of the rest of these. Small, medium, large, extra large, and a default. Well, I forgot my cases. Let me put those in there. All right. So small, medium, which will say that you're a size medium. L, which will say that you are a size large. And XL, which will say that you are a size extra large. All right. We will also add in here, because it's good practice, a default. And we'll just say invalid size inputted. Okay. And that'll take care of that. In that case, using a switch statement works just fine. Now, we could have done it the same way in here. All right, so let's rewrite this using an if. We could have said if size equal S. Let's grab one of these. We'll do the alert that says you are a size small. All right, and I'm just going to do some copying down here. So if your size is equal to S, you're a small. Else, if your size is an M, you're a medium. Else, if your size is an L, you're a large. Else, if your size is an XL, you're an extra large. And I don't remember what we said for in here. We just said invalid size inputted, so I'll grab that. So else, invalid size inputted. Now, did using the switch bias a lot? Well, 4, 24, it's about 20 lines. This, 26, this is actually less code. You may find in cases like this that using a switch is a little more self-documenting. So it's, again, as always, it's your call as a developer. All right? So that's my take on this, so you can see what they did in there. So, and also you need to put the break in, because if you don't, it just keeps falling through. Break sends you out of the switch statement. Otherwise, you stay in there. All right. There's also a ternary operator. It's the only operator with 3 operands. Okay. So if we look at that one, let's just give a quick example here. Again, I'll get rid of all this. And I'm going to say let number 1 equal 45. Let number 2 equals 67. Let max. Okay? And I can say this. I can say if number 1 is greater than or equal to number 2, this will work just fine. Max equals number 1. No problem. Else, max equal number 2. Totally fine code. Nothing wrong with it. Not a lot of code. What, about 6 lines? But I can rewrite that like this. Max equal, then put my check in here. And I can say question mark number 1 colon number 2. So I can replace 6 lines of code with 1 line. So this says, make this check. If the check is true, do what comes after the question mark. If the check is false, do what comes after the colon. So if it's true, number 1 is greater than or equal to number 2, take number 1 and assign it to max. If it's false, if number 2 is greater than number 1, then take number 2 and assign it to max. So in either one of these cases, max is going to be what? 67. All right? Totally fine. All right, nothing at all wrong with doing that. All right. So they give you examples. I gave you my own. I think they're just fine. All right. Now, they have a thing in JavaScript that's known as truthy and falsy. Falsy is everything that you see in that first listing. 0, the empty string, null, undefined, and an empty array. Also, I believe double quote 0 double quote is also falsy. All right. Other than that, basically anything else is what's called truthy. So falsy, truthy. All right. So you'll look right here, and this will actually say that this variable is not initialized. You can check for empty strings. You can check for the existence of something like a property. All right, statements that store a true or false value. Well, look, selected if state is equal to this or state is equal to that. You'd never use an and there because it can't be 2 states at once. But if the state you selected was either this or it was this, all right, then selected, so if this or this, with the or operator, let's see, that, if the state was one of these two, then selected would be true. Otherwise, it would be false. All right. And with the and, you have to both be greater than or equal to 18, and you have to be a citizen. And remember, the way that this works was short-circuiting. If this is true, you don't check this because of the short-circuiting. If this is false, you don't check this. All right. And here's checking for the existence of a property. Just you do that in a very similar way to the way that you check for a primitive type of value, except when you look in here, notice the question marks. Okay, we're going to get to that in a later chapter. I don't want to talk about that anymore right now. All right. So here are the terms that you relate to control structures. And I believe we've talked about most of those in here, other than the nullish coalescing operator, the optional chaining operator we didn't talk about. Type coercion we talked about earlier, and the rest I think we've talked about in here now. So they have this user interface for an invoice application. And you notice this will be a drop-down list. And based on what your total is and what type of customer you are, so if you're honored, it's a 40% discount, so you get $48 off. 120 minus 48 would give you 72 as an example. So there's the HTML, there's the JavaScript, and you'll notice the way that they've set it up. So here, they actually have an if inside of a case, which is totally legit to do. All right, before we go on to try catch, I think we're just about out of time for this lesson, so I'll pick it up in the next one.